Hey guys, all right. So this is a recording for 4.4 example 2. A rectangle has its base on the x-axis. So let's draw x-axis and y-axis because looks like it wants. Okay. X-axis, y-axis. Okay. A rectangle has its base on the x-axis and its upper two vertices on the parabola y equals 12 minus x squared. I normally rewrite this so I know that it opens down and it had a vertex at 0, 12. So 2, 4, 6, 8, 10. This is 8, this is 10, and 12. So I have my vertex right here. And I want to solve for the x-intercept. So what I'm going to do is I'm going to set this equal to 0. Move it over so I can have this. That means x equals plus or minus square root of 12. And square root of 12 is, I would say, what? Square root of 16 is 4. Square root of 9 is going to be 3. So in between 3 and 4. So I'm going to go make 1, 2, 3, 1, 2, 3, and 4, and 4. Okay, so you're going to have an x-intercept of this upside down parabola in between 3 and 4. No, you don't need to know exact value. It doesn't matter. Okay, so this is just a square root of 12. This is negative square root of 12. So those are your two x-intercepts. Let's read on further. A rectangle has its base on the x-axis, okay, and its upper two vertices on the parabola. So somewhere on the parabola, that's what it said. So a rectangle has its base, and again, we don't know where. So this is just a sketch of the rectangle. It does not mean this is what the rectangle or where it should be or how big it should be. Okay. So all I know is this point is x comma y, and this point is negative x comma positive y, and I do not know exactly where they are. But the question is asking, what is the largest area? Okay, so misspell area. So please correct this to make it area. What is the largest area the rectangle can have, and what are its dimensions? Okay. Again, so we are kind of solving the same sort of question, but this time is giving you slightly different scenario. It's a rectangle that it's inscribed underneath a parabola. So first, let's give this some variable, and here's something that you have to think about. Would you agree that this is an x dimension? Okay, so my base would have this whole thing, right, as 2x. Would you agree? So this is your base. Then the height, because that point is x comma y, so the height is still the same as just a y. So the height does not need to have 2y. It just the bases just need to be careful. Okay, so that's your height. So we're talking about the area again. So I'm going to go area equals base times height. Okay, but keep in mind your base is now 2x and your height is just, we're going to use, sorry, put in an h right there. I'm at the t right there. Your height is, let's use the variable y. Well, I have one equation and I have two variables. It's not going to be very useful. So this is where the y is going to come in. Whatever y is, it's on the curve. So that y value would be the same. So I'm going to take out that y and substitute it with whatever y it's given to you in the original problem and rewrite this area in terms of x. So I'm going to try to solve for x. So this is going to be 24x minus 2x squared equals area is in terms of x. And again, I'm looking for the largest area. So again, I'm going to do the derivative. Will give me the turning point, which is local min or local max. And I'm going to go, hey, derivative is 24 minus 4x. This is actually the third. Can you fix that for me? See? Actually the third. So this is 4x. Oh, then that's no longer 4x. And that's going to be 6x. 6x squared. Okay. Okay, so that's 6x squared. Now I'm going to solve for the critical point. So 24 equals 6x squared. Divide both sides by 6. So 4 equals x squared. X is technically plus or minus 2. Okay. And again, x is the distance. Okay. So you can think of it as I don't need a negative symbol, okay? But your base is going to be 2x, so the base is now 4. Did they give us a unit? No, just said. Okay, so no given unit. So base is now going to be 2 times 2, which is 4 units. So that's how big the base of this rectangle is going to be. Now the height, I already have a height equation. The height equation is y equals 12 minus x squared. So y is the height. Remember this? Okay, so that's going to be 12 minus, we found x. X is 2, so that's 2 squared. So 12 minus 4. So the height is going to be 8 units. So those are my dimensions. Now I need to plug it back into my area. Okay, so x was 2. So 2 times the height was 8. So this is 32. So let's put it together in a box so it's an organized matter here. So max area, or the largest area is 32 units square. Dimensions are 8 units by 4 units. Okay, now the common error that some of you are going to make is not multiplying this by 2. Can you see this right here? So make sure you multiply it by 2. Okay, now here's another example. A right triangle has one vertex on the graph of 9 minus x squared. And again, I like to write this in order. It's just how my brain works. Okay, there isn't anything wrong with not writing in order if you already see what's going on. This tells me that I have a vertex at 9. It opens down 1, 2, 3, 4, 5, 6, 7, 8, 9. And that means, that tells me I will have an x-intercept at 3 and -3. So here is the parabola opening downward. Okay, and this is my x-axis, and this is going to be my y-axis. So a right triangle has one vertex on the graph. Okay, so one vertex on that parabola, another at the origin. So one's at the origin, and third on the positive x-axis. So positive x-axis, 1 right there, sounds good. And third on the positive x-axis, so somewhere here. Okay, it's a right triangle, so you can make it however you want. Some of you can go, well, why can't I make it like this? Sure. Okay, as long as you meet the condition of a right triangle. And some of you are going to be creative and be like, well, can I just make it like this? Yeah, who am I to judge, right? And then some of you are going to be like, well, I don't like the way you're doing it. Can I just make this? Yes, you can make it however you want, as long as one vertex is on the curve, one vertex is on the positive x-axis, and one's at the origin. Okay, so whatever you want to do, whatever floats your boat, you can make whatever you want. So because that's just too many things, it's confusing, so I'm just gonna use this red one. Okay, okay, so here's what, this is the point x comma y. So my base is going to be an x base, and keep in mind that this x base does not go out all the way to 3, okay, because it's a right triangle. And then this y value is whatever it is, and the hypotenuse. Okay, so right away I know this height is y, whatever it is. Okay, and area of a triangle is 1/2, base is x, height is y. Well, guess what? I know exactly what the height is, right? Height is y equals 9 minus x squared. So it's 1/2 times x times 9 minus x squared. Let's make this pretty. That's going to be 1/2 x times 9 minus x squared. You can do the product rule, or you can just distribute, which I'm going to do. 9 over 2x minus 1/2 x to the third. Now I'm going to do the derivative. Okay, so this is going to allow me to do 9 over 2 minus 3 over 2x squared. I'm going to set it equal to 0. So this is 9 over 2 equals positive 3 over 2x squared. I will now get rid of 3 over 2 by multiplying by its reciprocal. I meant 2, okay, reciprocal. Okay, So as you can see, the 2's are going to cancel. The 9 divided by 3 will allow me to reduce it down to 3. So 3 equals x squared. So x equals positive or negative rad 3. But again, I'm on the positive side, so I'm going to pick positive rad 3. So that's my x location. That's my base. Now I'm just going to plug it back into the y equation, which y is already given to you. So I'm going to use that. Y equals 9 minus x squared. So y equals 9 minus rad 3 squared is just 3. So this is 6 unit. Okay, so my height is 6 unit. My base is rad 3. And is also looking for the largest area. So I'm just going to plug it back into the area formula. Area is 1/2 base times height, which is 1/2. My base is rad 3. My height is 6. So this is 6 divided by half is 3 rad 3 units square. So let's put it together in a box for organization purposes. Okay. So box. Max area or largest area is 3 rad 3 u squared. Dimensions are 6 units by rad 3 units. And guess what? We are done with this example.